Hello, I'm Randy Youngblood from Team Sparky Construction. Myself, along with Ruth Andrews and Jeff Chase, would like to present Adapting Old to Renew, the Hughes Warehouse Makeover. We wanted to explore how an adaptive reuse project was transformed from abandoned property to a modern, sustainable, high-performance building. I will discuss the background, scope, and some of the sustainable materials used on the project. Jeff will be discussing how the project addressed energy to include lighting, air, and water usage. Ruth will talk about the occupancy comforts of the building. Located in downtown San Antonio's illustrious Riverwalk urban area is a Hughes warehouse that was built in 1917 for storage of plumbing supplies. Overland Partners, a local architectural firm, ventured into an adaptive reuse project in 2012. The newly renovated facility received the 2015 American Institute of Architects Committee on Environment Top 10 Award for efforts incorporated architectural design and sustainability principles. Overland Partners' goal was to transform a dilapidated warehouse into a 26,000 square foot sustainable architectural studio while incorporating 2 additional tenant spaces. The project scope involved demolition of a roof section and constructing a steel frame with windows along the front of the studio. Since this was an adaptive reuse project, the ultimate goal was to reuse as much of the existing building materials as possible. According to the EPA, 534 million tons of construction and demolition waste was generated and placed in landfills in 2014 alone. 90% of that debris came from demolition. Obviously, a key leverage point would be to figure out a way to eliminate or significantly reduce construction and demolition debris in landfills. The Adaptive Reuse Project on Hughes Warehouse found a way to leverage that data and reduce the debris that went into landfills. To start, the project kept the existing 10,800 square feet double-width brick perimeter walls of the warehouse. That effort alone essentially saved $270,000 in demolition and new construction costs and kept 422,000 pounds of debris out of the landfill. Furthermore, they reused the existing concrete floors, saving $120,000 in construction costs and prevented 1.5 million pounds of debris from entering the landfill. The roof beams removed to create the courtyard were reused to repair damaged roof sections and as stairwell treads. Additionally, approximately 30 solid wood support beams were left in place and now serve as a grid for a workspace layout. The roof of the warehouse was upgraded with R20 insulation. A reflective thermoplastic polyolefin cool roof was installed, creating a solar reflective index of 98.6, reducing the building's island heat effect. The clear story window frames were modified to match the frontage window framing, and both were outfitted with 1-inch thick Solar Band 70XL low-E coated high-performance glass. Window shades controlled by an astronomical clock were installed along the clear story windows. This allowed control of sunlight into the building depending on the sun's angle in reference to the building. Finally, 65 kilowatt photovoltaic panels were installed on the rooftop. Now Jeff will discuss in more detail how the installation of these materials saved on energy usage.
Thank you, Randy. My name is Jeff Chase, and I'll be talking about lighting, air, and water. The lighting in the warehouse at that time was of a clear story type window, which means that they were very high up and only had views of the sky, but could also be open to ventilate the actual building. During reconstruction, windows were punched out around the building, which gave now over a 97% view of the ground around the actual building. By doing that, natural daylight was increased by 90%, and 77% of the space in the building could actually turn their lights off. Air quality in the building was once again could be brought in by natural air by those clear story windows, which were refitted to be opened, which meant that 60% of the space was within 15 feet of one of those windows to be operated to let in natural ventilation. In this slide, we have a couple different pictograms talking about the daylight study that was done and the indoor air quality that was done. The picture on the left shows that 90% daylight use coming into the building reduces the use of electricity to the lights by 77%. On the bottom right, you'll notice that it talks about the artificial lighting that can be brought down to 20% in the core and way below 20% on the outside perimeter of the building. The indoor air quality can be affected with the HVAC system in coordinates with the clear story windows that can be opened around the building, reducing the CO2 levels to 100% all the time for use. In this slide, we have two different studies that were completed. The one on the left was the daylight study. That talks about how 90% of the building uses natural daylight and can reduce the use of electricity to certain parts of the buildings up to 77% not using electricity on those lights. Down on the bottom right, you'll notice that it talks about how the interior of the building can be dimmed down to 20% and even lower on the outside of the building where there are more windows. On the top right, you'll notice the indoor air quality is 100% time below CO2 levels that is required for office space. And that is because of the HVAC systems that were installed and the use of the clear story windows that can be opened during office times. Water usage in the building is now nicely controlled. The landscaping is totally self-sustainable. It does not contain any irrigation because the plants that are used in the courtyard are indigenous to the area, which means it has no use for chemicals or pesticides. There are 4 50-gallon rain barrels around the building that take care of the vegetable garden and the storm sewer runoff that happens from rain. Water fixtures in the kitchen and bathrooms use valve arresters to limit water usage that is used throughout the building.
Thank you, Jeff. Hello, my name is Ruth Andrews, and I'll cover occupancy comfort for the Hughes Warehouse Makeover Adaptive Reuse Project. The materials and energy topics that Randy and Jeff covered all play a part in overall occupancy comfort of a building. But first, I'll start with design. In this project, the design team used collaborative building programming across 50+ designers to incorporate design elements such as more efficient workstations. They focused on the owner's request for the flexibility to restructure with ease and incorporated modular furniture in pods. A major win for the team to boost the green design was a redesign of a previously covered space into a 1,500 square foot courtyard, which improved daylighting and decreased condition space. This space has also become a social hub for the neighborhood for yoga classes, CSA exchanges, and art exhibitions. Next, I'll cover how the building is constantly monitored to optimize occupant comfort and how the users feel after spending time in the building. The team installed integrated systems that not only optimize building performance to reduce energy consumption and therefore reduce cost, but they also maintain optimal working environments. For example, shade control is governed by astronomical clock, and there are individual thermostats in each conference pod. Data loggers track CO2 temperature, relative humidity, and light levels. 1.5 years after building occupancy, a survey was conducted to determine occupancy satisfaction for the overall building and the workstations. The result was 80% satisfaction. The survey showed that many of the design team's innovations were successful in satisfying the users. Last, I'll review some data on green buildings and cognitive function. In 2015, the Harvard School of Public Health published an article on the impact of green building on cognitive function. The study was researching whether people work smarter in green certified buildings. The results showed that workers scored 26.4% higher on cognitive function tests and displayed 30% fewer sick building symptoms when working in a green certified building. In addition, the study showed that certain factors such as CO2 levels and ventilation rate all had significant independent impacts on cognitive function. While the Hughes Warehouse is not a green certified building, our team believes the occupants will benefit in a similar manner as occupancy comfort level is high, so therefore they will be working smarter. In conclusion, today, Randy, Jeff, and I have reviewed the Hughes Warehouse Adaptive Reuse Project and how an abandoned, empty structure can transform into a high-performing green building through the application of sustainable measures throughout design, construction, and building occupancy. We walk through the materials reused and technologies optimized for energy savings and building comfort. The end result has achieved a high satisfaction rate with the occupants and has brought new energy to the community. Thank you for listening. I hope you have enjoyed our presentation.